In this video, we are going to see the first quantum number, and that is principal quantum number. This principal quantum number, the spelling here is PAL. This is represented by small n. It gives the main energy level to which the electron belongs. The allowed values of this quantum number is starting from 1, 2, 3 and so on. So very important student, this n value is never equal to 0. It is never equal to 0. So its value will start from 1, 2, 3. Now if I say n is equal to 1, 2, 3 or 4, how I will denote those orbitals are, this is k, l, m and n, like this. If I see the nucleus and the position of the electron, now the first orbital will be k, next will be l, then m, means this is n is equal to 1, n is equal to 2, n is equal to 3. So what is happening, as the value of n goes on increasing from 1 to 2 to 3, you see that the distance from the center of the nucleus up to the electron, that also goes on increasing, and therefore the energy will go on increasing from k to l to m and to n. What it means, as the n value goes on increasing, the energy of that orbital also goes on increasing. So what it gives you about the position of the electron is, so for that let me take one example. If I say the electron is in n is equal to 4, what it means? This is the nucleus. This is the first n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4. So the first electron what I am locating is here. The second electron if I see, which is in n is equal to 2, then where is the position, student? That the electron is here. So by knowing the principal quantum number, I can tell about the position and the distance of the electron from the center of the nucleus. If I compare both the principal quantum numbers here, I can say that the electron which is in n is equal to 2 is closer to the nucleus, right students? And the electron which is in n is equal to 4 is farther from the nucleus. So this is the meaning. So I can tell about the position of the electron from the center of the nucleus. Now what are the electron numbers what I should fill in the main energy level? So let us see that. So there is a formula for this, and the formula is 2n square. This is called Bohr-Bury rule. Now what is this Bohr-Bury rule? For that, let us say n is equal to 1. Means which orbital the electron is belong? That is to the K shell. Now when n is equal to 1, how many electrons will be there? So it will be 2, 1, because this is the quantum number which is represented here, square. So how many electrons I can fill in the first orbital is 2 electrons. When n is equal to 2, means the electron is in L subshell, then it will be 2 square, so it will be 8 electrons. Similarly, n is equal to 3, so it will be 3 square, so it will be 18 electrons. So you can find the number of electrons you can fill when n is equal to 4, and you can try this for your practice. Now let us see the next thing about this principal quantum number, and that is the energy. To calculate the energy of any electron in the main energy level, the formula which is used is, if I want to see the hydrogen spectrum, then the energy in the nth orbital, it can be given by a formula, and that formula is 2 pi square me4 n square h square. So this formula is used to calculate the energy of the electron in the given main energy level. Now what is this 2? You know it's a constant here. This is 3.14 or 22/7. This is the mass of the electron. This is the charge on the electron. This is the principal quantum number to which the electron belongs, and this is Planck's constant. So in short, what principal quantum number gives you is the main energy level to which the electron belongs, and it gives you the distance of the electron from the center of the nucleus. Thus it gives the average electron cloud of any particular given nuclei. Thank you, students.